Are you interested in game development but don't know where to start? I felt the same way, but in just 1 month, I went from having no experience to creating my first game demo. Here's how I did it and how you can too. Before we get into that though, let me tell you a bit about myself. My name is Sebastian and I'm a 4th year computer science, economics, and math student. I've always been interested in game development, but pushed it aside as I was told that it was unrealistic and too risky when compared to more traditional software development. In my 3rd year of university, when choosing the courses for my final year, I saw a game design course that looked super interesting. Unlike my other courses though, this course is so popular that you need to apply for it. To stand out, I decided to create a game demo to include in my application. With 1 month until the application deadline and absolutely zero game development experience, the clock was ticking and it was time to get started. There are many game engines out there. From my research, the 4 most popular ones are Unity, Unreal Engine, Game Maker, and Godot. There is a use case for each one, and I encourage you to do your own research to figure out which one is best for you. In my case though, I really value software that is updated continuously. For the sustainability of my games, I also want to make sure that I choose an engine with a fair pricing structure. For those reasons, I chose Godot, which is both completely free and open source, leading to continuous updates and suggestions created by members of the community themselves. In fact, if you want to add something to Godot, you can go ahead and do it, and it might get implemented. With my engine chosen, I decided to look at a few tutorials to get started. All of these resources will be linked in the description below. I started with Tutemic's Godot for Absolute Beginners tutorial, where he explained Godot fundamentals such as scenes, nodes, and scripts. I then watched a video from Heartbeast's Heart Platformer series, where I learned more about different node types, sprites, animations, and so on. Having learned the basics of Godot, I decided it was time to pick my game genre and try out a larger project to prepare for my demo. Digital card games are one of my all-time favorite game genres. Over the past few years, Legends of Runeterra and Slay the Spire are some of my most played and most beloved games. I love the idea of creating a game in this genre because the focus is on the design of the game and its mechanics, both of which I have many ideas about. I remember coming across a video from Godot Game Lab a few months ago, which was part of a larger series he has on creating a Slay the Spire-esque game in Godot. I decided to watch his series in its entirety to get a grasp on what it would be like to work on a Godot project at a much larger scale. For weeks, I would spend hours every day following his series and making sure to take notes on fundamental game design concepts and techniques. I learned about game design patterns such as event buses and state machines, what to consider when designing a game's architecture, and how to use resources to bring your game to another level. After several weeks of this, I decided to pause the tutorial to focus on creating my own demo. There was only a week left until the application deadline, and I wanted to create my own game from scratch, including its architecture, code, and visual assets. This was a huge task, but one I was excited to complete. In software design, there's a rule known as the single responsibility principle, which states that every unit of software should have a single responsibility. Having an extensive background in software design and software engineering, this rule is second nature to me now, so you'll see me commonly refer to new pieces of software by what they are responsible for. The first feature I implemented were cards. I created a card handler scene, which serves as the brain of the card and is responsible for delegating card-related actions to the appropriate handlers. Each card handler contains a card UI node, which handles the card's visuals and interactions with user input, and the card resource, which defines the card's attributes, such as its name, cost, and rarity, as well as its effect when played. Finally, each card handler contains a card state machine node, which implements the state machine design pattern, determining the card's state and defining how it should transition between states. To design the card UI, I looked to existing card games for inspiration. I took note of what information each card conveyed, how this information was structured, and what I liked or didn't like about each card. In particular, I really like how Slay the Spire's cards convey card types through subtle design changes. The art on skill cards has a square border, while power cards have a round border, for example. I also liked how Legends of Runeterra's cards are not perfectly rectangular, allowing for certain elements of the card to poke out or use unconventional shapes. With this in mind, I designed my card UI with subtle changes across my 4 card types: attacks, spells, auras, and characters. I created a container for each different card type and hid them all by default, allowing the card UI script to show the correct container and fill it in with the card's information depending on its type. For all 4 types, I included a color diamond to further indicate its type, an icon for its mana cost, a name, and a description. Dave Geltema's 5 golden rules of game cards graphic design was a huge help here, as I learned to put the most important information about my card, namely its type and its cost, at the very top. I then spent some time learning pixel art in order to create my card art. I'll include some links to tutorials I found useful down below. I learned about basic pixel art concepts, shading, composition, shape theory, and so on. I decided to use Sprite for my art as it contains many useful features, such as its symmetry and lasso tools. If you're looking for free pixel art software, there are many out there, such as GIMP and Piskel. I want the first of my game's heroes to be themed around writing, as it is a huge passion of mine. I want his mechanics to be centered around rewriting the fate of battle through powerful status effects, as well as bringing characters to life as actual units who fight alongside him. In the future, I hope to create other characters based on different artistic fields, and since my game is set in a forest, I decided to title it Battle for Brushwood, capturing its artistic themes, forest setting, and roguelike genre. For my hero's basic attack card, I drew a pen flying through the air, as if he had thrown it at an enemy. Once I was happy with the design, I added it to my card UI's card art as a placeholder and moved on to the actual mechanics of the card. I decided that all cards would start in an idle state, where they are resting in the player's hand. When hovered, they transition to a hovered state and poke out of the hand. If the player clicks on a hovered card, it becomes selected and can be dragged around the screen, and if the player lets go of it or presses right click, the card enters the release state, at which point it can be played. Next, I created the encounter scene, where the player encounters enemies and uses their cards to defeat them. I created a simple forest background in Sprite and included it as the background of the scene. I then created sprites for the player, a character fighting alongside them, and 2 enemies. I then created an HBox container for the player's hand and instantiated a few card handlers to test out how the cards would work. By adding Area 2Ds to the encounter scene, the card UI scene, and the enemy sprites, I was able to detect when these areas overlapped to know when a released card should be played and on which enemy. I added some logic to check whether a released card should be played, and I then created an event bus to handle events that would affect various nodes, including a card being played or released, and made released cards snap back to hand if played on invalid targets. After realizing that characters and enemies are functionally identical, I decided to create them as instances of a new unit scene, which would contain all the nodes needed for a unit to work properly. Each unit has an aforementioned Area 2D hitbox to detect when cards are played targeting it. They also have 2 UI bars, one for stats such as HP and status conditions, and another for their current intent. To determine intents, I needed to figure out how to implement unit AI, which stumped me for a bit. I had to design moves in a way that they could be easily updated and applied to various types of units, while making sure that each unit had a specific set of moves they could use, each with a specific probability of being executed. To solve this, I decided to create 3 additional resources. First, the move resource. All moves have a target type, which represents what its user can target, such as a single enemy, a single ally, or itself. Moves also have an effect type, which represents how it affects its targets, such as by dealing damage, applying a debuff, or both. Moves also have an execute function, which is defined by each type of move, in which the unit using the move executes the move on its targets. Next, I created the move handler resource. All move handlers have a move pool, which contains the moves they can choose from, each with a specific chance of being chosen. Move handlers are able to pick a move at random, and, based on the move's target type, as well as the allies and enemies of its user, obtain the targets of said move. Move handlers can then execute the chosen move on the chosen targets. The final resource I created was the species resource, which defines a specific species of unit. A species has a sprite, which shows what it looks like, a max HP stat, and a move handler, which determines that species-specific move pool. To tie everything together, all I need to do is assign a species to a unit, who can call on their species move handler to handle all of its moves. By designing moves in this way, I am able to create a move once and apply it to as many species as I want, each with a potentially different chance of being executed in combat. I am also able to prepare a move in the move handler first, to display the unit's intent, and then actually execute these moves when needed. To finish off the unit scene, I added functions for taking damage and updating its UI. I also added an intent handler node to set the unit's intent depending on its prepared move and targets. In order to display the effect of the move, I set the icon of the intent UI depending on its effect type, together with a string representing the magnitude of the effect, such as damage. To display the move's targets, I wrote a script to draw a line between the unit and its targets when hovered, which I think looks pretty cool. at least for this demo. The player scene is similar to the unit scene, with functions for taking damage and nodes such as the stat bar. In addition, the player scene contains a hero resource, specifying the chosen hero's stats, such as max HP and mana. I added a play function which calls a specific card's play function, and handles things such as mana and determining if the card was successfully played, to either delete it or snap it back to hand. For the last few days of development, I'm just going to skim over the features I added. This is partly because the devlog is already pretty long, but also because these days were very chaotic, and I barely had time to think about each feature. Ready? Let's go! I created a status effect resource to apply unique effects such as gaining strength and falling asleep. I created a status handler scene which is responsible for applying and activating status effects applied to a player or a unit. I created an effect resource to apply effects on a target, such as dealing damage or applying a status condition. I added a unit handler class which contains units as children. Unit handlers keep track of its units' allies and enemies, activates their status conditions, and handles their deaths. I created a card pile resource, which is a collection of card resources. I instantiated card piles for the discard, draw, and exhaust piles, as well as the hero starting deck. I created a card pile handler scene, which contains a card pile resource and handles everything to do with that resource, such as drawing or discarding cards. I added a card pile handler for each of the card piles I created and added them to the encounter scene. I drew a sprite for each one of these to better visualize the card piles. I created a new card which allows the player to gain block. I created 2 species of enemies, each a combination of a mythical creature and a forest creature, and each with 3 unique moves. I created sprites for them with help from Soltoon's videos on pixel art. His videos also helped me create the Rider Hero sprite, which I drew holding the pen and the book seen in his base attack and spell cards. I created strength, drowsy, and asleep status conditions, and drew an icon for each one. I drew icons for each move's effect type to create clearer intents. I drew icons for HP and block to use in the stat bars. I added a mana icon which updates dynamically if the player's mana changes. I added an end turn button which the player can click to end their turn. I added a turn manager node which is responsible for executing the core encounter game loop. Turn start statuses are activated, the player gains mana and draws cards, units declare their intents, and then the player gets to play cards. When they end their turn, their hand is discarded, turn end statuses are activated, units execute their moves, and the player's block is reset. Finally, I added a label which appears at the end of an encounter, letting the player know if they won or lost the battle. That was a lot. Now for the actual submission of the demo. With the final features of the demo implemented, I pushed my changes and uploaded the project to itch.io. I included links to these pages in my application, sent it off, and hoped for the best. I then added some more details to these pages, which you can check out below, to see any progress on the game. I also hope to someday create a Discord server where you guys can help create the game alongside me, with suggestions for new features or desired changes. And with that, we've come to the end of this devlog. In the background, you'll see gameplay of the demo we came up with. I know this was a very chaotic start to the game, but I'm happy with what I was able to do in such a short amount of time. If you enjoyed this video and want to see more progress on this game, as well as general game development or software engineering content, be sure to leave a like and subscribe. See you next time!